Let us discuss the problem maximize the profit as the salesman from LeetCode weekly contest 359. The problem states that we are given n houses, right? And we are also given an array offers. Every index of the array offer has three values, that is start index, end index, and a value gold, where uh, start represents the starting index of the offer and end represent the ending index of the offer, and gold represent the value that we will receive from this offer. So if I have n houses, then start to end represent that from start there is an offer to buy houses from start to end for the value gold. What we have to do is we have to select some of the offers such that we can maximize the value of gold we receive. Let us see with the help of an example. So this is an example where there are five houses and we have three offers. Let's see how this goes. So we have these three offers. Okay, so this is the start index of the first offer, this is the start index of second offer, this is the start index of third, and similarly these are their ending indexes, and these are the profits, that is the gold value we get. So what we have to do is we have to maximize the gold value we receive. So if we see what all choices we have, so the choices we have is for example, we can choose this offer and not choose this offer, choose this offer, right? So this way we have a lot of choices to go through. And finally what we have to do, we have to make some choices such that those choices are possible, which means that uh, two offers do not coincide with each other, and we get the maximum value of gold. So basically we have two choices for every house, and those choices are uh, for every offer we have two choices, and those choices are either to choose that offer or not choose that offer. Supposedly, let's say I choose this offer. If I have chosen this offer, I have bought houses from index 0 to 0, that is the 0th house, for a gold value of 1. Now I move to choose my next offer. Let's see, I come here. I see this offer is to buy houses from 0 to index 2, but the house 0 is already sold, so we cannot choose this offer. So we move to next offer. Uh, it offers us to buy house from index 1 to 3 for gold 2, so we can choose this offer, and we receive a gold value of 3 in total. This way there could be many possible choices. One could be we don't choose this and then we choose this and then we don't choose this. Considering all these possible choices, we have to find the maximum possible value of gold we can receive. So it's a very standard DP problem. At every index, we go at every index and either choose it or not choose it. And if we have chosen some house, then we move to a house that is possible to choose. For example, here I have bought houses till 0, so I will only be able to choose this offer and not this offer. So we have to choose accordingly. So first thing I do is I sort all the offers by their starting index. So let me go and straight away code. So first thing I do is I sort all the offers by their starting index, and then I create a function. Let's say my function name is func. It takes parameters at as index, my offer vector, and a value n which represent the size of offers. So what this function returns me is it returns the max gold I can get by choosing some offers beyond offer index, right? So this is the value this function return me. So my answer would be nothing but function of I start from index 0 and just pass this array to it. Okay, so now let's code this function. So let's first think of the base case. Base case would be when my index value reaches the end. So that would be right, and in this case I would return 0, because if I have completed iterating all the offers and no offers are left, so I cannot choose any gold from here. Now what I do is I let's say my first choice would be don't choose this offer. So what my let's say this answer variable denotes the maximum gold I can get. So my first choice is by not choosing the offer. So what value will I get? I will simply say this thing. Why? So what I say is just move to the next offer and don't choose this offer and get that value for me. And my next choice would be to choose this offer, right? My next choice would be to choose this offer. So let's say for that answer would be nothing but function, and our value the next offer I move, it will not be index plus 1, because as I told you here, if I choose this, I cannot move to this. I will have to directly move to this. So we will have to handle this case here. Let's say we will handle in a minute offers and n. And what value will I get? Because I have chosen this offer, so I can collect this value from here, this much gold from here. So let's try to find this index. So my current ending index of this offer is nothing but this. So what I need to do is I need to iterate over all the offers beyond this offer and find such a offer whose starting index that is greater than my current offer's ending index, nothing but ending. If I found such index, let's say this variable denotes my next index. So I will make next index equal to I and break out of the loop. So I know that next index denotes the next offer that is a possibility to choose. And I just pass this here. And now I just return my value answer. So let's see, does this work? Yeah, so this gives me a correct answer, but this solution would give me TLE. Why? If I see for all the n indexes, at every index I have two choices, either choose or not choose. So if I look at total choices, it would be 2 to the power n, which is an exponential solution, and n is as big as 10 to the power 5, so it would not pass. So I need to apply some memoization here. If I see, if I like try to draw a tree here, so let me explain you how I can do this. Okay, so let's say, so what I'm trying to explain is this value of index, I will reach this index multiple times, right? So for example, I made a choice, I choose this, not choose this, choose this, and there were some more offers, and I reached this index. Somehow I reached this index. So I can reach this index multiple times. In this tree, this index will occur multiple times. And I am going to calculate this answer for this index every time. But I don't need to do that because I can just store that into an array and use that every time. So I will make an array whose size will be nothing but, and initialize it to -1. So what I'll say is, if value for this index is pre-calculated, that is it is not equal to -1, I'm just going to return this value and not calculated completely again. Okay, and I can also say that I have calculated this value, so I can store this. So let's try to run this now. Okay, it gives correct answer. Let's try to submit. It still gives a TLE. Right after even applying dynamic programming, it gives a TLE solution. Why? If you see how many states do I have here, I have n states here. And what other calculation I am doing here? I am doing running a loop of length n. So my total time complexity would be n square. For every index that is reached once, I am making a computation of n length. So my total time complexity is n square here. So this next index I need to find some way optimally, not in n time. So let's see how can we do that. If you remember, I initially told you that this is sorted. The offers are sorted by starting time. So if I see in this case, my ending was 0. Okay, so I know that I have to find an index whose starting is greater than 0, that is whose starting is 1 or above. So I can see it is here, right? So basically I'm trying to say is, let's say values are like this. So I need to search a value, it is 0, I need to search a value greater than 0. So I can say this. So basically this is a sorted array and I can apply a binary search here. And I basically need to find upper bound of this number. And this way I will be able to obtain my next index. So let's do that. So now what I'm going to do is I'm going to replace this complete thing with a binary search. So to do binary search, let's write a function here. Because our array is of such form, we cannot directly use the upper bound function here. So I'm going to write the a custom upper bound function. What it takes is it takes L and R values and my offers array and the value from whose greater value I have to find. So what I'll do is by L is less than R, I'll find the mid value, and if offers value at mid comma 0 is actually greater than value, so I can say this is a valid value. So I will move my, it is a valid value, so I will move my R here. R is going to be mid. Okay, else what I'm just going to return is I'm going to move my mid in this case, else my answer is going to be just L. Okay, so my next index is going to be nothing but I find the upper bound from where, from index plus 1 to n minus 1, and I pass offers and I pass the value, that is nothing but this. But if you see, we are still missing an edge case, that is if there is no such element. Okay, if there is no such element, this will still return me n minus 1. So I don't want n minus 1 in that case. What I want is, let's see what I would want. So if this value is even less than equal to my this value, so what I will say is my next index should be n. Let's say it's n, so it will hit this condition and return me 0. Okay, so yeah, this way we do this. Let's try to run this. A compilation error. Okay, okay, it's giving me correct answer. Let's try to submit. Okay, it's accepted. So the time complexity of the solution is now, but so first our time complexity was something like this, 2 to the power n, then we reduce it to n square, then we reduce it to n log n. I mean n is the length of offers here, not the number of houses, remember this. Okay, so this is the solution to this problem.